man.
Let's go to the final meeting.
I know. Wait, if I can just get this thing to work, we can get on our way in a few seconds. Oh, come on. This thing is painful. Jesus Christ, come on.
There's a bunch of observatory customers commands. You're going to have an unusual number of clicks from that country. I foresee for the next 6 months.
More than usual?
More than usual on that or that country.
Okay. Yeah, the overall this, I mean,
But the other
it's pretty complex. I mean,
people is, yeah.
it's like the 5-page contract, very accurate. Specific means, you know, it's not like things world class contract, it's not something super big to a local thing, but
I noticed that I didn't know very much about many of the things that you were doing, but I noticed that was on the family of your,
yeah, I mean,
in your,
it was definitely very
yeah,
they were just surprised that they were
more
like,
specific.
always,
Yeah. I guess it is what it is. Hopefully something somewhere to grab. It's always good to feel that the different markets.
Only two points to do?
Well, whatever you feel like is fine.
What are you talking again about?
Complexity?
Yes.
No, 10 minutes. Cool, guys. Thanks for coming here. I just wanted to show you guys off some new tools that you could play with, maybe, specifically Python. So the big question is, why Python, right? We have all these tools that do statistical analysis or data analysis or all that kind of stuff anyway. So why go for something like this? Well, there's a bunch of different reasons. I mean, there's large community of users, tons of well-maintained packages. There's adoption of Python in the sciences is growing pretty fast. Like biotech, especially for some reason, seems to be kind of really getting onto this. And then econometrics is like a close second. But these two things, for example, STATA also is pretty has a pretty large community and pretty well-maintained packages and that kind of thing. But where Python comes in handy is it's a really good general-purpose language. So a lot of times, I don't know if you guys have ever run into the situation, but you'll have to write some code in some other programming language, and then to do some things. Like, for example, Michele was crawling some websites to be able to grab some address information to create a data set, which he then had to pump back into like a different environment. So, for that kind of thing, Python is really, really good. There's a ton of libraries that do pretty much anything imaginable, from crawling stock market data to websites to opening up tons of different, file formats, all the different kinds that you could ever need, et cetera, et cetera. And it's production ready. So, if you're going to build something in this, you know that you could actually it's not necessarily just for the analysis step, but you could actually put it in front of users. Like lots of different websites use Python for this kind of thing. Dropbox is a really big one. Instagram uses Python. ton of others, like Pinterest. Those are like large names that I can think of right now. But the final thing is that I think it's a joy to use. Like there's a lot of programming languages are just kind of a pain in the ass, and they just kind of bog you down with a lot of syntax. But I think Python's a little different, and I'll show you guys in a second. There are a few other things. It's open source, well, that comes in handy because it means it's free, so you don't have to pay any licensing fees. But it's also pretty good because, you know, kind of from an altruistic perspective. But let's put that aside for a second. But it runs on anything. And so because of the kind of miracle of commodity hardware, today you can go and buy computing power by the hour. So Amazon Web Services is a big example of this, where you can go and you can get like a 32-core, I don't know, like 128 gig ridiculous supercomputer for like $1 an hour, right? So you could buy like 8 of these and have pretty much a supercomputer for the price of a latte, which is, you know, pretty handy. And you know, this is a dig at STATA. It can keep more than one data set in memory, which comes in handy. It actually blows my mind that STATA does this. I guess it's kind of a trade-off because it makes things easier, but at the same time, you know, it's a pain in the butt because writing things to disk and reading them from disk is probably the slowest thing you can do with a computer. So the more things you can keep in memory, the better. And then, so...
multiple instances of STATA.
Okay, sure.
You don't move them easily from there.
In any case, so there's a lot of this going on because so still like I get a lot of people saying, oh, you know, like, well, Python's free, right? It's built by people who are volunteering, essentially. No one's paying for it to be produced. So how could it be as good, or how could it be, you know, even a decent competitor? Well, I'll show you guys what it can do, and I think you guys can decide the conclusion of that one. So now let's get rid of this, and I'm just gonna show you guys a few examples.
Which version are you using?
So I'm using 2 right now, but so what I'm specifically using is there's this thing called IPython Notebook. So what it is basically, if you've ever used like MATLAB or like Mathematica, right? Exactly. It's basically a document where you can. Sorry, let me make this a little more. So I'm using 2 right now. Okay. So you can basically merge in your text and your code and your graphs all together, right? And you can create this kind of cohesive document where you tell a story bit by bit. And this is pretty good and pretty great for research, where, you know, you can actually explore things as you go, and people can see every single step that you took as you're in the process. So let me actually let's just go.
This is platform code.
To the what?
So this is
Wakari.io. Yes. So this doesn't actually quite matter, but so Wakari is basically a free service where these guys basically put IPython Notebook already there for you, and you know, you don't have to install anything, you don't have to deal with anything, and it's all there.
Can you briefly introduce what the book is? I think
yeah, but before we even do that, let me just let's start with actually. Let me show you guys a little bit of what Python looks like. So, okay, so let's start from the basics, right? So you have numbers. So you have 3 is a number, 3.0, and it's like, oh, you know, 3.0 gives you back. Then you have, you know, operations between numbers. So you can, you know, multiply numbers, you can divide numbers, no problem.
When you divide by 0,
it'll be very angry.
Okay, so let's start from here.
But okay, so those are kind of simple things, and then you have strings. So you're like hello a string, right? Pretty simple. You can add strings together. And the syntax is like pretty intuitive, right? It's like a string and another string. So when you put them together, you got a big one, and that's no big deal. So you can do more interesting things. You can say, okay, let's say, what about membership, right? I want to see if there is hello exists in this thing, right? So I can say hello in hello a string, and I'll say true, right? But then if I go for like Jello, then it's going to be like, well, false, because Jello isn't in the string. So that's kind of how strings work. And then you have variables, and things aren't typed. So you can have you can have a variable called a number, and call it 3, and then I don't know, another number equals 5, and then a number plus another number, right? So pretty nice there. And you can also, since things don't have type, you can try to add things that don't match, and then Python will get angry. It's saying, "What are you doing? You're trying to add a number and a string together." But the benefit is that you can basically get up and running, and your code looks like your thought process. And I'll get more into that in a second. But so let's do something else. Yeah. Okay, so then you have functions. So functions are basically little pieces of code that you can put something into, and then stuff comes out the other side. So len is a function that basically returns a number of things in a sequence. So I can say, okay, how long is a string, right? And I'll say, oh, the length of it is 11. And that's not very complicated. But then let's see. So let me show you how you write functions. So you can say, this is basically how you define functions. You say, okay, define a function called hello, and then give it a parameter. So let's say you give it a name, right? And then, oops, not quite done yet there. So then I can say, okay, print hello plus name, right? It makes sense. So you give the function hello a name, and then it'll basically take that name, add it to hello, and print it out. And it seems pretty straightforward. So it can be like hello Joe. Nope. So the way it works is it's based on white space. So the fact that like anything that's nested within this is basically indented by a certain amount. And so that's like a really controversial aspect of it. Is some people get really angry at it. They're like, I have to indent all my code, and then other people are like, well, this is really nice because you basically you won't ever see badly indented code because it's just not going to work.
And also that you don't use because of that.
Right, exactly. And so it gets rid of most of the really common issues where you're like, you're looking at your code for 30 minutes and you realize you forgot a semicolon somewhere, right? You don't have any of that. Okay, but let's say, so then what happens if I don't pass a parameter? Then it's like, oh, it gets angry because it says, well, hello takes exactly 1 argument, but you gave it 0 arguments. So what you can do is you can actually give default arguments. So you can say, okay, hello, Joe, right? And so now when I call it with our arguments, it'll call it Joe. But then if I say Jane, they'll be like, hello, Jane. And so another thing about this is that you can actually specifically refer to arguments this way. So you can say name equals Jane, or name equals, Josh, and it'll actually. So this comes in handy when you have 20 different parameters, and this happens a lot in statistics packages, and you don't want to give an argument to every single one of them. You want most of them to be the default value, and you just set one of them. So anyway, I'll show you guys a little bit more later. And then you have other things. You have lists. So 1, 2, 3, 4. Pretty simple. And then you can refer to things inside the list. So the second thing in the list, well, it's 0 indexed, so it's 3. The third thing in the list is 4. And then you can say, give me a range. So you can say, give me from 1 to 3, and it'll give you 2 and 3. And then you can say,
what is the syntax if you wanted to, let's say that you wanted to write a matrix or a vector? Do you write it that way, or?
Let me get to that.
But when did you say 1, 2, 3? Why didn't you just go 2 to 4? Because 1, 2, 3.
Because everything is 0 indexed.
No. But then third element is 4.
So 0th element, first element, second element. Oh, right. Yeah, it's not last inclusive. So the second index is not inclusive. That's why. But you can also give it a step. So you can say, okay, go backwards. Well, I guess that didn't work as much. Right.
In between is 1.
Oh, right. That would make sense. So you can say 3 to 1, go backwards, and then you can say go backwards 2 at a time. Well, okay, let's do this. So you can manipulate lists in pretty handy ways, and I think this is like pretty good to get us started in some actually useful stuff.
So square brackets are.
So squares.
Say the sets.
Yeah, it's a list. Yeah, it's a sequence. Yeah.
But it doesn't have to be integer.
Yes, so it can be anything. So you can have, like a list of, well, you can list of, so this is actually also valid. And
if you want to use this for matrix algebra, you need to have a package that can work with lists, or
exactly. So you have a package that, so I'll show you the syntax a little bit later, but the way it works is you can actually put a comma in the middle here. Oh, sorry. Well, you can put a comma in the middle here, so it would actually more look like this. So it could be like, you'd be like A13, and it'd give you like the first row, third column.
Would it be A03?
No, like not a range, but let's say this was like a two-dimensional thing, right? So if it was like this, and let me get to it. Let me show you guys examples. Like that's going to be way clearer. So I'm going to show you basically this one library called Pandas, and what it does is it's basically this. It doesn't have to do with the animal panda. It's like Python data analysis, and it's basically this big tool that gives you access to matrices. The idea of a data frame, if you guys have used R, it's like it's basically like a giant matrix that also has labels on on the axes, and you can index them, etc. And so let me show you. So let's load up some data. Okay, so there's also a bunch of handy things that you can do. So this environment lets you, I can hit tab, and it'll show me basically every single little thing that I can do, right? So it'll automatically complete what I'm writing. So it actually makes the process way easier. So I'm going to use this function that basically lets me grab some data from a CSV file. And so here's a little documentation on what this function actually does. And so you can look things up immediately as you're using them, which is really handy because you don't have to pull something else up and look at what they're doing. But it's saying, okay,
This documentation is from the website or is from
Oh yes, it's from IPython. But the thing is, even in the command line, so let me show you something else that's interesting. So here's what actual Python looks like. And so even here, there's a function called help, right? And you can say, for example, help len. Oh, well, I thought that worked. All right.
You can like len.
So it'll actually pop you up and give you documentation. But in any case.
So you can also use len for array, for size of array?
Yes, so you can use len for everything. So that's the nice thing, is that everything is kind of vectorizable, and anything that works on something that's list-like will probably work on any list-like thing, including 2D and 3D matrices and that kind of.
Is this from CSV better than CSV?
It's a shortcut. From CSV. Yeah, so that's actually a good point. So there's actually quite a few other things you can read from that are not here but are actually in the main thing. But I'll show you guys later. But you can read from STATA files, Excel documents. You can read from a SQL database. You can read from like anything. But let's look up. Okay, so I have some data I got from the World Bank. Okay, interesting.
But how does it know where you have it?
So okay, so this is because yeah. So I basically just put it in the same directory. But let me see what I.
Why did you CD? In this notebook, you didn't set the path yet.
Because it was already basically the notebook is running in the certain directory, and the files are like basically inside of that directory. So yeah. But let me see. Oh, I think I know what's wrong. So let's look at.
This notebook is not in the same directory. That's what I was saying.
Oh no, that's fine. But it's actually. So I know what's wrong. So let's pull up the data file and see what it looks like. So okay, so you have country code, indicator name, indicator code, and all this looks good, except you have these 2 extra lines here, right? Which is a pain in the butt. So what you can do is you can go and you can actually tell it to skip those lines. So I'll say, okay, let's look up the documentation again, how we actually go away. How we actually do that. So header, or I think header does it. So let's see. Row to use as header, skip prior rows. Exactly. Okay, so that's what we need. So let's say header equals 2. Okay. So it looks like we got something. So now I can dump the entire thing out, and it'll actually show it to me as a nice table. But since there's so many rows and columns, it's actually gonna cut off parts of it. But you can see that it's already at a reasonable state, except there's a lot of NaN. So this means there's like not a number, and this means that they just left these fields blank. So now we have to kind of like deal with this whole problem, right? So we gotta like take this thing and turn it into a reasonably usable data set. But let me show you some things first. So you can say, okay, give me information about this. So here's a list of all the columns. It says there's 252 entries, Aruba to Zimbabwe, and a bunch of different. So most of these years are actually empty, like forever. And you know, in 1996 we start getting some data. 2000 we get like maybe a decent amount. And then, so like 2000 to 2010 seems like a decent enough chunk to get, it looks like. So let's see. Okay. So let me show you what happens if you get one single column. Right? So you can do this, and you can refer to specific columns, and it basically shows you everything in that column. And you can, you know, refer to a range of columns. So you can say 2000 to 2007, and well. Okay, actually that's my fault. So I have to do this. So you can do this, and you can refer to specific columns, and it basically shows. Okay, so here's what I'm doing here. So you can specify. Remember how when I was using lists, I used this syntax, like from 1 to 3 or 1 to 4, to specify a range. So with two-dimensional things, there's basically, you know, two things they have to specify. So over here you have to put the row, and over here you have to put the column. So for the row, you know, like, okay, so for the row, you know, I can say give me 0 to like everything. But a shorthand way of saying that is to just not give it the things, and it'll be like, it'll just take, you know, everything possible. And then for the columns, I'm gonna tell it, okay, give me 2000 to 2007. And okay, so it gave us back the same thing, except, or maybe, did I say 2010? Yeah. So, okay, so that is there because there's actually multiple different ways that you can index matrices. So one of them is like numeric only, and the other one uses like the labels of things. And IX is like a hybrid version that uses like both the numbers and the labels. And it's basically almost as if you would do this, but it lets you like specify string labels. So basically, when I say 2000 to 2010, notice that these are actually, they're not numbers, they're text fields. So it knows about the range 2000 to 2010 only because it knows like what order that the rows are in. So for the columns, like I could say, like I wouldn't have to say give me from 1 to 7 and 1 to 4. I could say give me from, yeah, Aruba to like, Argentina. Well. Oh, yep. Perfect. Thank you. Okay. So yeah, you can specify ranges of rows and ranges of columns. But for now,
That's a Python thing, or is it a Pandas?
That's a Pandas thing. Yeah. Okay. So we got a ton of different things, but we have a lot of these rows that don't even seem to have any usable data, right? Like, so there's Afghanistan, there's like no data. Austria, Belgium, Benin. So we want to be able to drop these like empty values. So there's, you know, there's already built-in stuff for that. And so let's see what that does. Actually, so when you're, this actually should not work. So you can say, okay, drop the like not available values, and drop it given a certain axis. Is that right? I think that's right. So let's see actually if that worked. So without it, we had, okay, Aruba, Andorra, Afghanistan, which all should be going, I think. Yep, they're all.
Yeah, it's if every value is rows.
Right. And then let's see, okay, but is that true? Let me see if Argentina. Yeah, okay, so Argentina has a few. So let's look at what Australia looks like, just to double check that we got the right thing.
So without it, you have Cuba or Afghanistan, which all should.
Okay, so it looks like it dropped Australia too. Well, that's handy. Okay, so we have a reasonably clean data set. Okay, so let's start like actually doing stuff with this.
Look at what Australia just.
So let's see what a really simple plot of this looks like. Oh, that's not quite what we wanted. So, I know what's going on. So let's flip the axes. So right now we have research this way, right? We have the years on this side, and we have the country names on this side. But what we actually want is kind of the other way. So we can say, okay, research.transpose. And then you actually have them the other way. So now we have the these guys as columns, and years as rows. And I can say, okay, research equals research.transpose. Okay, so that kind of did what we wanted, except there's a ton of different countries. So here's what I'm going to do. I'm going to filter out some of the countries. So I'm going to say, okay, give me, let's say I had a list of countries of interest, right? And I had, you know, or actually, ooh, so another interesting thing, I'm going to have to,
Okay, so that kind of did what we wanted, except there's a ton of different countries.
So I actually have the names of the columns. Okay, let me actually change something. So here's what I'm going to do. I'm going to run it until here. This guy. What I'm going to do is I'm going to actually look at... Oh, I took out the country codes. That's what I did. Okay, let me see if I can actually keep those country codes because they're going to be really handy. So let's look at the raw research again. Okay, so country code is here. So we can actually change the index of the thing. So right now these guys are indexed by, you know, Aruba, Andorra, Angola, blah, blah, blah. But we can actually use the country code to be able to do the same thing. So I can say, okay, set index country code. Okay, and now, as you can see, like the first row is the country code, and you have, you know, it's pretty much what we want. Okay, and then now we can, you know, get all the columns from 2000 to 2010. Okay. All right, now we have everything, country codes and transpose and everything. Okay, so now let's say, okay, we have a bunch of countries of interest. So let's say they're like, you know, where should we do? So Japan's a good one. Let's do USA. Let's do Turkey. Let's do Germany. And then someone, give me one more.
Armenia.
Is it ARM? Oh, okay. Perfect. So countries of interest. So now what I'm going to do is I'm going to say, okay, so give me only the, so I'm going to use the same row and column syntax, and I'm going to say, okay, give me all the rows, and instead give me only these columns. Just give me the countries of interest. And that, oh, great. My bad. So that actually didn't work. Why did that not work? So let's see what this does. Oh wait, sorry, exactly. Because I forgot that I transposed the whole thing. Bingo. Okay, so now let's say plot this guy.
This is the R&D ratio of the countries.
Wait 1 second. Yes. So this is R&D per GDP.
Oh wait, sorry. Exactly.
Okay. So now we have something kind of useful. So we can say, okay, you know, Japan is pretty high. They're using like 3% GDP and consistently almost increasing, but not quite. And then on the bottom you have Armenia and Turkey. And then USA and Germany seems to be about the same in terms of percentage, of course. Yeah. And also, sorry. Anytime, like, intervene and yell at me when something doesn't make sense.
Can you repeat the question for people who are listening?
Oh yes. So, question.
When you use the drop NA,
Yeah.
it drops either the row or the column that doesn't have that has one cell missing. Or
so actually, so the way it works is.
Go back to the
yeah.
To show the.
Yep. So here, pd.data frame.drop NA. So you can actually there's a ton of different options of like how you can. Sorry, this screen size is killing me.
So actually, so the way it works is.
So okay, I can specify the axis. I can say okay. You can say so. Any is basically if any one of them is not available, nuke the whole thing, or you can say all, which means that if the whole row is unavailable, then get rid of that row. And there's a ton of different options. So you can actually like there's another function drop that says you can drop specific values, right? Not every data set has NA. They have someone decides to put some stupid thing in there.
The question that I have in mind is that let's say that you for a country you have data in every year, but one of the years. Okay, so would you be able to do like say calculate the average?
So actually,
with the NA, because for instance in STATA,
yes,
it recognizes that if a dot is missing, so it calculates the thing. In MATLAB, you can't.
So let me actually show you this cool thing called interpolate. So I actually have a list of things that I want to talk about, but I think like I don't know if I'm gonna have time for all of them, but let me try to show this off for you. Or here, let's do it over here.
So let me actually show you.
Research clean, we'll call this.
I actually have a list of things that I want to talk about, but I think
okay, now.
I don't know if I'm gonna have time.
Okay, so we have research clean here. Let's say we have. Okay, so let's say we set the 0, 1 thing to be, well, right now,
so we have research clean here.
Right? So now I can say research clean dot interpolate. And so this gives me actually a ton of different options, right? So you can say, okay, you can interpolate by row, you can interpolate by column, you can have it be linear, polynomial, quadratic, any kind of ridiculous thing. You can actually even supply your own interpolation function. So let's say you know that the numbers go at a certain kind of sequence. Let's say you have a yearly basis of data and you want to calculate like a monthly basis and you know it only increases like X amount per month. Then you can say, okay, interpolate this data and you can give it your own function that calculates that kind of thing. And so yeah, like all that stuff is doable. But okay.
In this graph that you were making, in MATLAB, I would then stop and I would start making like the given dotted lines by using interface and construct the code afterwards. So something like that.
I see. Interesting. No, you are limited to making graphs with code. But the thing is that the graphs are like ridiculously configurable. I'll show you. Let me actually. Do I show you now or do I show you later? Is the question. Okay. Well, I guess I'll show you now since you brought it up. So there's a ton of different libraries that do what you want, and so matplotlib is the most common one, and it's basically it's like almost a copy of the MATLAB graphing thing, except it's made like Pythonized and a little simpler. And so here is like a ridiculous different kind of array. You can have error bars, you can have facet grids, you can have histograms with error bars, you can have density plots, you can have quivers with density on the side, you can have, you know, polar coordinate graphs, squiggly things.
But like, does this work with Pandas?
It does. So I'm actually going to show you, like, we're going to keep graphing things as we go. You can style your graphs to look like squiggly lines. And like, let me see if there's anything specifically super interesting here. Okay, I'll just keep scrolling down just so you guys actually get like a impression of like the breadth of like what you can actually do. I think that's a CT scan that puts things on. Let's see if there's anything else interesting. Okay, another polar coordinate one. All right, but you kind of get the idea. And so the idea is that it's like most of the libraries do the simplest possible thing first, right? So you can tell it to just, you know, plot, and that's what we did, and we didn't give it any parameters. So it'll try to guess, like it'll guess the axes, it'll guess the colors. You give it multiple columns, it'll give it different colors. So, you know, the motto is, you know, try to do the right thing. And then if you want to configure it, then you actually specify the extra parameters, and it'll, you know, do all that stuff. So actually, let me. I'll save the really cool graphs for the end. But let's see. Okay, so I wonder what else I had in store for you guys. Okay, so there is a summary statistics function that basically lets you summarize everything over time, but that's fine. Resample, this doesn't quite matter. Okay, let's do some stats stuff. Right, like this is all well and good, you know, cleaning data and that kind of thing is pretty nice, but let's do some statistics. So what I have for you guys is the OECD, what is it? It's like the life satisfaction index or whatever. So I'll show you guys what that looks like in a second. So I'll say, okay, grab something from CSV, and it's in data. OECD.csv. Okay. So you have a bunch of different columns. So you have countries on one side, and then you have indicators over here. And so the idea is that, you know, you have housing expenditure, employment rate, job security, personal earnings, and then all these things come together to come up with this one final kind of number that's supposed to be a 0 to 10 value of life satisfaction in the country. And so what I'm going to try to do is, okay, I'm going to say, let's let's try to predict life satisfaction given all these other variables. So I'll do like a little regression. But the best way to test the regression is to split the data set into half. So I can say, okay, so I can say partition equals.
Let's try to predict life satisfaction given all these.
Well, actually, I don't know how many rows we have, and I don't know if there are that many. So maybe I'll do like 1/5. Oops, that's not what I meant to do. So I say, okay, you know, give me the number of rows in OECD and divide that by 5. Did I not call that? Oh, OECD raw, right. You know what? I'll just call it OECD. Okay. Now I'll say, okay, OECD test equals, or I'll take some of it to be the control, and I'll say, okay, OECD.ix, give me the rows from 0 to partition and all the columns, and then OECD tests.
But the partition might not be integer, which causes a problem.
Well, it should be fine. We'll see. If it breaks, it breaks.
I'll take some of it to be the, and I'll say, okay, OECD.
And then I'll say, okay, give me the rows starting from partition, going to the end, and give me all the columns. Okay, so it looks like that works. So OECD control. So it looks like, you know, we have something reasonable. Now let's get the. Now I forget exactly. So now I'm basically just going to tell Python, okay, get me the libraries that do statistics things, and then get me the library that does ordinary linear squares. Actually, it should be this guy. Yeah, so what this means is basically, so if I just did this, then this thing that I just imported would be called API. And I'm just calling it something that's easy to remember for me. So I can say, yeah. So I can say, you know, import OLS as, you know, ordinary linear squares, etc. But yeah. So let's see. In the interest of time, I'll just because it's actually 2:52, and I can't believe that actually happened. Well, you know what? It's probably better if I just show you guys what I had. So, okay. Well. Okay. So, here's an interesting thing. You can do a correlation plot, right? And it's basically just some blah 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 dot corp, and it'll show you, okay, you know, things that are really correlated are red, and not very correlated are blue. So you can say, okay, personal earnings is correlated to household adjusted disposable income, which makes sense, right? If you have more earnings, you have more disposable income. But then, like, you know, time devoted to leisure and personal stuff is not correlated at all to dwellings without basic facilities, which makes sense. If you don't have basic facilities and you're really poor, you probably are working all the time to make up for that. And so yeah, but so here's what I was doing. I basically split the data set into two different pieces, and I have, you know, the control part and the test part, and then you basically pass it. Pass it the test part, And so I have, the dependent and the independent variable. So I have, just the life satisfaction column, and then on the other side I have, everything, which is test part, and then I just basically drop the life satisfaction column, and I have, everything remaining. And I say, okay, fit the model and give me the result. And so let me see if I can actually show you guys. So you can say, okay, give me a summary of the regression, and it'll give you, all the statistics. So you have, R squared, F statistic. You have all the coefficients. You have standard error, and everything.
So is it, like, for instance, easy to split this out as a data table?
That's a good question. I don't know. I would be surprised if the answer wasn't yes, because you can do like all these things like, okay, take a look at this. So I can turn this into a text field, and I can say, hello world, and then I can say, x equals sqrt4, and when I run it, it actually renders the LaTeX into, actual text. So like, since they have that, I figure they have something for this too, but in any case. Okay, so you run the regression, and then you can actually plot the regression. So you can say, okay, show me the actual prediction versus what we actually had. And so we have, some pretty reasonable results. Like Australia was actually somewhere around 7.2, and we actually got 7.5 or whatever. And Chile, interestingly, looks a little far off. But in any case, so regular regressions. And let me see if there's anything else interesting over here. There's one thing I was doing. It was about merging two data sets. So basically, I was getting the Human Development Index. And okay, so you have the Human Development Index, and let's see what that looks like. Dot. Say, give me the first few rows. Okay, so you have all these indicators, and then the final HDI value, and you have the 3-digit country codes. So the 3-digit country codes are something we can actually merge with the other previous data set on. So there's some things you can do with that, but we're like getting so close to the end. So I'll just show you some more really interesting things that you can do. If I can actually get Google Chrome for you guys. Okay, so there's actually this really cool thing where there's this graphing library called D3, and what it is a graphing library that you can use for online things. And so you can actually use, there's something that connects that with Python, and you can actually use these things like within your IPython notebook. So you can have, well actually, let me see if I can show you on my notebook. Okay, so here's an example, right? So you have your graph here, but you can actually drag the graph and move it around, and you can zoom, and obviously this is a little bit more useful in scatter plots, but you can do pretty much any kind of interactive features. So you can have, so over here you have like draggable points. Over here you have, I like this one, it's linked brushing, so I can select this guy and it'll actually like select the same region and all the other ones. And so the really nice thing about this is when you're presenting research, you're not necessarily stuck to giving people a static document. You can give them an IPython notebook and hide the code, and it just looks like this web page that has all your text, and it has all your supporting graphics, and which is really handy because people can look at your data in a way that's not not necessarily very viable right now. You know, you can have, obviously, you can have little tooltips, and you can customize how the tooltips look like, and it'll show you all the data values for everything. And
how hard is it to get there?
So
just that you already have the code and now
right. Here's what it looks like, actually. You basically, instead of so here's the code. It's the exact same code. So normally plotting would look like this, and you just add this little thing, and now it's magic. And so yeah, but I mean so the nice thing about this is, if you're really willing, you can customize everything, and you can have your plots interact with your actual website and that kind of thing, and you can inject arbitrary code in there that does things.
And can you add this kind of interactive plots into, say, a PowerPoint presentation or something like that?
That's a good question.
LaTeX.
So it's
I've seen
HTML.
interactive LaTeX.
So I think it should work in PowerPoint because so it's HTML basically. So anything that runs HTML should be able to run that.
But for the
Oh, right, it is JavaScript. That's true. I think you can. Can you include like a frame on PowerPoint? Maybe. I don't know.
and also move to the browser.
Yeah, so you can, I mean,
something that
share
was
the
the
file.
banana.
That's true.
But it's so it's something that anybody with a web browser
Can see. Right. So here, let me show you another cool thing. So here is, just to show you the kind of inherent coolness of IPython notebooks. Here's this website called MB Viewer, where people actually dump all their notebooks, and people put some really interesting things here. Here's like a textbook on probabilistic programming, right? And it's pretty much a textbook, except you have all these plots, and this entire book is written in IPython notebook, right?
Can we see the Python code?
Yes. So on top there should be so this guy, I think, downloads the notebook, and you can run the exact same thing on your computer. So you have the source code and the actual thing. And so here's like an interactive plots thing. Plotly is like another library that does interactive plots. But here, let me show you something else. Yeah, so here's like your book, right? And then here's all the interactive stuff like along with it. And you don't necessarily need to write that much more code to like get everything to be interactive. And I think this is like kind of an improvement over a regular textbook, because you can see all the code is there and everything's reproducible. And in any case,
I always thought like, what was the class of Python compared to her? And this could be the difference.
I mean, I think it's like it's really like, it's not necessarily just interactive plots. It's that there are people out there who are trying to build stuff like this.
But it's not broke.
Right. Yeah. And okay, so there's a bunch of different ones. Like if any of you guys used R, ggplot is a really awesome graphing library, and it's a little bit different. It's based on this kind of like the idea of a grammar of graphics, and it's someone basically decided that they would kind of formalize how you describe a certain graph, including the way it looks, what kind of graph it is, etc. And this is basically an implementation of it in Python. And it makes pretty complicated graphs like pretty short and fast to create. So here's a faceted grid, right? It took 3 lines to create this. But in any case, I think that's probably the most I should show you. Oh, okay, one more thing. So there's this one package that does statistical graphs, and so I think there's some interesting things here. So if you wanted some more exotic things like, you know, violin plots, or here's like a joint plot. So you have a regression, you have a scatter plot, and then on each side you have a histogram of that axis only, and you know, a trend line for that. And so, you know, really the possibilities are pretty endless. So I think the value here is that, I mean, there probably are some very strange and exotic things that you can do in STATA or SAS or SPSS or whatever that you can't do here. But I think this hits like a pretty good 90% case, and I think Python is just a really good language for glue. Basically, you can take, you know, tons of different kinds of things together. You can take a library for crawling a web page. You can take a tool for data analysis. You can take a tool for computing, you know, exotic kinds of regressions, and you can put them all together in one place, and it doesn't take that much effort to do it.
You could still use STATA, right? You can just, if you don't, because I'm not sure that I trust all the statistical libraries, because I don't even know how it would actually work in STATA, but in STATA, it's not my fault.
Ah, okay. That's an interesting take.
But you could use STATA and produce like whatever the output is that you want to process later.
That's true, and dump it into a CSV, do like aggregate, and pull it in here. Right. Yeah.
Yeah, I know that's not what you would.
No, but
And for all these graphs, like, can you export PDFs or?
Right. It's like you can export basically like vector versions. You can save them as PDF. You can save them as.
Because for many of them, you need a browser to show them. Right?
So the interactive ones, obviously, like you can. I don't know if you can do a PDF of that, but everything else is like exportable as vector.
A lot of PDFs.
Yeah.
When it comes to those data, one of the problems of, for instance, data is that you have to load everything into the memory. So if you have like a 20 gig data set, like one that we are going to use now, the problem is that you cannot do it
Right.
in Python. Is there a way that to choose either a column or a row that you want to load?
Yes.
You can load parts of the data set with STATA.
When it is a state data set, but when it's a text file, you cannot.
Right. So yeah, the answer is yes. You can do that. You can give, you know, offsets and everything, and you can. There's actually ways to deal with, you know, really large data.
Because
where,
for instance, SPSS, it doesn't load everything into the memory, so you can do complicated calculations without loading
all of it. Right. So there's actually ways to. Yeah, there's definitely ways to do that. Like you can. You can basically have it such that, yeah, it doesn't load the entire thing into memory, and you work on parts of the data set bit by bit, and you know, but you don't like it. That happens transparently. And, yeah. So I think we're out of time. Yes, and it's well. Thank you, everyone. Yeah, should have done more stuff, but anyway.